Okay, let's look at our Unit 7 Mixed Problems worksheet, and let's look at number 9. We have a collection of coins, so probably a chart. We have dimes, and we have quarters. And let's see, we have a unit value, we have a quantity, and we have a total value. This is a total review of what we did earlier in the year. Okay, the unit value of a dime, I'm not going to write $0.10. I'll just do 10 cents. So I'll do unit value is in terms of cents. And the quarters have a unit value of 25. Each quarter is worth 25 cents. I don't know how many dimes I have. I don't know how many quarters I have. And I don't know how many coins I have. If I knew how many coins I had, I could use one variable. But since I don't know how many coins I have, I'm going to use 2. And the total value, we just multiply across. So we multiply across 10x, and this becomes 25y. Now, we do know from the problem that the coin collection is dimes and quarters, and it amounts to $5.35. Well, $5.35 is the same thing as 535 cents. So one equation is super easy to do right away. 10x, however much my total value of its quarters, plus 25y, my total value of quarters, equals my total value of the coins. Boom. My second equation is a little more annoying. It says twice the number of dimes exceeds the number of quarters by 5. I've got 2 ways of writing this. I got twice the number of dimes. Well, my number of dimes is x. So twice the number of dimes exceeds the number of quarters by 5. So I can write 2x minus y equals 5. I can write 2x equals y plus 5. I can write 2x minus 5 equals y. I mean, it's just that we have the twice the dimes equals the other number. It's bigger than the other number by 5. So it exceeds the number of quarters by 5. All right, so these are my 2 equations. Let's think about this. I can probably use substitution if I get y alone. So I'm going to take this equation and I'm going to turn it into, I'm just going to subtract 5 from both sides. Y equals 2x minus 5. Hope that's okay with you. I just subtracted 5 from both sides and I flipped it just so the y could be first. I don't know why. I didn't have to do that. And now I can substitute anytime I see a y. You see that? So let's rewrite the first equation using substitution. Still the 10x, still the 20 plus 25, but now y is equal to 2x minus 5. We're substituting. Equals 535, the number of cents. Total value in cents. So 10x plus, we do a little distribute. You get a 25 and you get a 25. Let's see, 25 times 50x minus 5 times 25 is 125. And we just bring down the equals 535. Let's see, 10x plus 5x is 60x. I'm just going to bring everything else down. I could have done 2 things in one line, but I don't want to get confused. So now I'm going to add 125 from both sides. So I have 60x equals 10. 4 and 2 is 6. 660. This works out really nicely. So if I divide both sides by 60, x equals 11, right? Divide by 10, and then 6 into 60 is 11. So what I just figured out is the number of dimes is 11. Now let's see what the question is. How many of each coin are there? All right, so we have dimes. We have 11 dimes. And let's see, how do we find the number of quarters? Well, we can pick either of these equations. Or we can even use this one. Hey, check it out. So we had the number of dimes, we know, we're finding the number of quarters. Well, y equals 2 times the number of dimes minus 5. Okay, y equals 22 minus 5. Y equals 17. So we have 17 quarters. You're amazing.